I'm going to show you how to write a polynomial function if you know your zeros. If you know your zeros, you can change them into factors and create a factored form of a polynomial equation. All solutions for this particular polynomial will have the form a times your factors. So let's turn the 0, 7 into a factor. So that would be x minus 7. The multiplicity tells us how many times that 0 occurs. So this factor occurs twice. So we'll use that as our exponent. Then we'll turn negative 1 into its factor. So that'll be x plus 1, and that has a multiplicity of 3. And then 2 is x minus 2 with a multiplicity of 1. So all solutions for this set of characteristics right here will have this form. Now they tell us our leading coefficient is 1, so we can give the exact solution or the exact polynomial for this particular set of characteristics. So our final answer here would be f of x equals 1, which we don't need to write, times x minus 7 squared times x plus 1 cubed and x minus 2 to the 1 power. So that would be our answer for example number 1. Now on example number 2, they give us a point and not the leading coefficient. So we'll have to do a little bit more work, but we'll set it up in the same way. We'll start off in the form that all solutions should have, and that would be a times, we'll turn negative 2 into its factor, so that would be x plus 2 with a multiplicity of 2, so that'll be the exponent. And then 2 would be x minus 2 with a multiplicity of 1, so we don't need to write an exponent, it's implied. And 3 is x minus 3. So this is the form that all solutions will have given only those zeros. But the problem here tells us that it contains the point negative 1, 36. So we can find the exact equation or determine the leading coefficient with that information. Remember that this point is an x and a y. So we can use that x and that y in this set up factored form. Remember, y equals is the same thing as f of x here. So let's plug in what we know. So we know the y is 36, so we'll write that here. We are looking for a, so that's going to remain a variable. And everywhere I see an x, I will replace it with negative 1. So negative 1 plus 2 squared, here's an x, so we'll replace it with negative 1 minus 2, here's an x, negative 1 minus 3. We have to do a little cleaning up. So if we clean this guy up, it's negative 1 plus 2, which is positive 1 squared, so we end up with 1. Negative 1 minus 2 is negative 3, so times negative 3. And negative 1 minus 3 is negative 4, so times negative 4. Bring our a down and equals 36. If we combine all of these guys right here, we end up with positive 12. So we have 36 equals 12a. And we can divide both sides to isolate the a. And so we know that a equals 3. So a equals 3. So now we can just plug it back in to this equation right here and find our final answer. So your final answer for this polynomial would be f of x equals, we'll replace a with our leading coefficient of 3 times x plus 2 squared times x minus 2 times x minus 3. Now you could easily check that by plugging it in your calculator and making sure that it goes through the point negative 136.